In addition to Z effective, there is this feature of atoms that is the atomic radius, and this is basically just saying how big are these atoms. And since we can't actually measure these unless they're bonded, the way they measure them is actually in an elemental form of the atom, where they have a couple of these atoms close together in some sort of bond. What they do is they measure the distance between individual nuclei, because they can't really see the electron clouds. They can model the electron clouds, but they can't observe it. And so they bond them together and say that the electron clouds extend essentially out to the edge, or 1/2 the distance between the two nuclei. Okay, so 1/2 distance between nuclei is what we call the atomic radius. And the atomic radius is given in this with this unit of angstroms, which is 1 times 10 to the negative 10 meters. So 1 angstrom is 1 times 10 to the negative 10 meters. And so it's kind of like the atomic mass unit, the equivalency for length or distance in atomic scale for the atomic mass unit that we use for mass, so those weights on the periodic table. Okay, so that's the bonding distance, and it is governed by the effective nuclear charge of the atoms, and it is also governed by how many electrons that those particular atoms have. And so if you look at the trends for the periodic table, as you move across the periodic table from right to left, the effective, or remember, the effective nuclear charge moves from left to right, but as you move from right to left, you're getting a larger and larger radius because of the increasing or decreasing in this direction effective nuclear charge. Remember, effective nuclear charge is +1 for these elements, +2 for these elements. Move over to here, it's +3, +4, +5. Well, as you're moving up, because those outer electrons are feeling less of a pull, the shell, when they're feeling a greater pull, the shell is kind of constricted. When they're feeling less of an effective nuclear charge, those electrons float in kind of a larger space. They're almost, almost free to escape, but not quite free to escape. And so they float in a larger space. Well, as you're moving down rows, so as you move down rows, you see an increasing atomic radius also. The reason for that is because you're essentially having more and more electron shells. As you move from the first row, where you have 1 electron shell, you've got 2 shells in the second row, and so on and so forth, all the way down the rows. And so since each shell is outside the next shell, remember my analogy for those eggs with the eggs in them, the eggs keep getting smaller and smaller. Well, the inner one is smallest, you get one on top of that, and that's on the outside. It becomes bigger and bigger as you move it on. So that is the trends for atomic radius.